Imagine a world where it rains gasoline, where rivers of liquid natural gas carve canyons through mountains of ice harder than steel, where the air is so thick and the gravity so gentle that you could strap on a pair of wings and fly. This world exists. It's real. It orbits Saturn. And it might be the strangest mirror of Earth in our entire solar system. And last year, NASA scientists found something in these lakes that made the entire astrobiology community hold its breath. We'll get to that. But first, let me show you where we are.
This is Titan, Saturn's largest moon, the second largest moon in our entire solar system, bigger than the planet Mercury, and the only world beyond Earth that has a dense atmosphere and liquid on its surface. That's not water. That's liquid methane, natural gas. On Earth, you'd pipe this into your kitchen to cook dinner. Here, it fills entire seas.
In 1655, a Dutch astronomer named Cassini-Huygens pointed a telescope he built himself at Saturn. And next to it, he spotted a tiny dot that no one had noticed before. He called it Saturni Luna, Saturn's moon. We call it Titan. For over 300 years, nobody knew what was under that orange haze. The atmosphere is so thick, 4 times denser than Earth's, that no telescope could see through it. Then, in 2004, the Cassini spacecraft arrived at Saturn, and in January 2005, a small probe called Huygens, named after the man who found this place, dropped through that haze and landed here. The most distant landing in human history. And what it found changed everything we thought we knew about this moon. But Titan has another secret, one that Cassini found hiding beneath all this ice.
Somewhere under my feet right now, there's an ocean. Not methane, water. A real ocean of liquid water mixed with salts and ammonia, 50 to 80 kilometers below the surface. And that changes everything about what this place might mean for life.
But we'll come back to that. First, I want to show you something.
It's raining, not water, methane. On Earth, this is the gas that heats your home. Here, it falls from the sky.
And it does everything that water does on Earth. It evaporates from the surface, forms clouds, falls as rain, carves rivers into the ice, flows downhill into lakes and seas. And then, it starts all over again. Titan has a complete hydrological cycle, just like Earth. The same process, completely different chemistry.
It's as if the universe took Earth's water cycle, swapped out every single ingredient, dropped the temperature by 200 degrees, and said, let's see if this still works. It does. Titan's 3 largest seas are called Kraken Mare, Ligeia Mare, and Puga Mare. Together they hold about 80% of all the liquid on Titan's surface.
Kraken Mare is roughly the size of the Caspian Sea, the largest lake on Earth. Ligeia Mare was measured by Cassini's radar at 170 meters deep. That's deeper than most of the Great Lakes. And the composition? About 75% ethane, 10% methane, 7% propane, with dissolved nitrogen, butane, and hydrogen cyanide.
These aren't puddles. These are alien oceans with chemistry more complex than anything we found on any other world. Right now I'm floating on Kraken Mare, the largest body of liquid on Titan, roughly the size of the Caspian Sea. Except this isn't water.
This is liquid methane and ethane. If I fell in right now, I wouldn't drown the way you'd drown on Earth. This liquid is about half as dense as water. I'd actually float higher. But the cold would kill me in seconds without this suit. Minus 180 degrees Celsius. Your body heat would actually boil the methane around you into gas, creating a vapor barrier right before you freeze solid. Recent research published in 2024 confirmed something scientists had suspected for years. Titan has waves. Real waves. Methane waves, driven by wind, crashing against the shorelines of these seas, slowly eroding the coastline, reshaping it, just like water does on Earth. Benzene, a molecule we consider toxic on Earth, falls from Titan's atmosphere like snow. It dissolves into these lakes until they're saturated. Then it builds up on the shores and lake floors as sludge, before being eroded away by ethane rain. And in 2024, scientists at the University of Hawaii discovered that Titan has a methane clathrate crust, methane gas trapped inside the ice, up to 10 kilometers thick. This crust acts like a blanket. It insulates Titan's interior, keeps it warm, which means the ice shell beneath us isn't cold and rigid. It's warm, and it's moving.
This moon is alive, not biologically, not yet, but geologically, chemically. Titan is one of the most active worlds in our solar system. So, could you live here? Let's find out. This is not science fiction. Titan's atmosphere is 4 times denser than Earth's. Its gravity is 1/7 of what you're feeling right now, wherever you're sitting. A human being with a pair of wings strapped to their arms could genuinely fly here. Not fall with style, not glide for a few seconds, actually fly. Take off from the ground, gain altitude, soar for hours. It's one of the only places in the solar system where this is physically possible.
Titan is one of the few places beyond Earth where you wouldn't need a pressurized spacesuit. The atmospheric pressure here is 1.5 times Earth's. You just need thermal insulation. And something to breathe. Now, you couldn't just walk out there in a jacket and a mask. At minus 180 degrees, exposed skin freezes in seconds. But the point is, you don't need to fight the pressure. And that changes everything.
That's it. And an insulated suit and an oxygen mask. Everywhere else in the solar system, the Moon, Mars, Europa, you need full pressurization. One crack in your suit and you're dead in seconds. Here, a crack would be an emergency, but not an instant death sentence.
The atmosphere also protects you from cosmic radiation. Unlike Mars, unlike the Moon, on those worlds, radiation is a constant, invisible threat. Here, Titan's thick nitrogen atmosphere and Saturn's magnetosphere shield you. No caves required, no underground bunkers.
And fuel? Look around you.
Titan has hundreds of times more liquid hydrocarbons than all the known oil and natural gas reserves on Earth, combined. You could burn methane for energy, split water ice for the oxygen you need to combust it. You could make plastics from the surface hydrocarbons, build your habitats from materials manufactured right here. The aerospace engineer Robert Zubrin put it simply. He said, "In certain ways, Titan is the most hospitable extraterrestrial world within our solar system for human colonization."
But there are problems. Sunlight, or rather, the almost complete absence of it. Titan receives about 1% of the sunlight Earth gets.
Solar panels won't cut it. You'd need nuclear power. And then, there's gravity. Throughout this episode, we've shown you people walking, working, moving almost normally. The truth is, it wouldn't look like that. Titan's gravity is only 14% of Earth's, lower than the Moon. Every step would carry you off the ground. Every gesture would float. We kept it grounded for the experience, but the reality would feel completely alien. And what that does to a human body over years, decades, we honestly don't know. And the distance. Titan is 1.2 billion kilometers from Earth. At current speeds, the trip takes 7 years. Mars is closer. Mars has more sunlight. Mars has more gravity. But Mars has almost no atmosphere, lethal radiation, and no fuel. Titan is farther, darker, colder. But it has atmosphere, fuel, radiation protection, and arguably, more resources for long-term survival than any other world we know.
The commute is terrible, but the view isn't bad. But living here is one thing. What if something already does? Remember that secret I mentioned? The ocean beneath the ice?
Cassini confirmed it. Gravity measurements, radio signals from the Huygens probe during its descent. Somewhere between 50 and 80 kilometers below Titan's surface, there's a global ocean of liquid water, mixed with salts and ammonia. That alone puts Titan on the short list of worlds where life might exist. An ocean of water, hidden beneath the ice, heated from within.
But that's not what made headlines last year.
In 2025, NASA scientists published a study in the International Journal of Astrobiology, and what they found was this. In Titan's methane and ethane lakes, simple organic molecules can spontaneously arrange themselves into vesicles. Vesicles are tiny, hollow spheres. Think of them as bubbles, with walls made of organic molecules. On Earth, vesicles are what eventually became cell membranes. They're the boundary between inside and outside, between chemistry and biology. And they can form on their own, no biology required, just the right chemistry, the right conditions, and the right liquid. Titan's lakes have all three.
Let me be clear about something. We have not found life on Titan, but we may have found the process that creates it. What if life doesn't need water? What if it doesn't need sunlight? What if all it needs is chemistry, energy, and time?
Titan has all three. It has a methane cycle that's been running for billions of years. It has organic molecules more complex than anything we've found on any other world. And now we know, its lakes can build the architecture of cells on their own.
We haven't found life on Titan, but Titan is showing us how life might begin. That is Dragonfly, NASA's next mission to Titan. Not a rover, a rotorcraft, about the size of a small car. Imagine a Mini Cooper with 8 helicopter blades. 875 kilograms. Nuclear powered. 8 rotors. And it's being built right now.
Dragonfly passed its critical design review in April 2025. Engineers at the Johns Hopkins Applied Physics Laboratory in Maryland began full construction in early 2026. The launch is scheduled for July 2028 on a SpaceX Falcon Heavy. After a 6-year journey, it will arrive at Titan in 2034. And then, for more than 3 years, it will fly. From dune field to crater floor, from methane shoreline to ancient impact site. 70 miles of exploration, 20 to 30 different landing sites. Each time it touches down, it drills into the surface, collects samples, and analyzes the chemistry of whatever it finds. It will be the first controlled, powered flight on any natural satellite in our solar system.
Right now, as you're watching this, engineers in Maryland are building the machine that will fly through those orange skies. And when Dragonfly gets here, it might find the answer to the question that keeps us all looking up. Are we alone? You know what gets me about this place? It's not the methane seas, it's not the ice mountains or the orange sky, it's the familiarity. Rain, rivers, seas, weather, seasons, erosion. shorelines shaped by waves. Every single one of those things exists here, on a moon 1.2 billion kilometers from home, with completely different chemistry, at temperatures that would kill you before you could blink. And yet, the process is the same.
But let's not romanticize this too much. This place would kill you in ways you've never even thought about. Minus 179 degrees Celsius. Every surface you see right now is cold enough to shatter steel. The air you're breathing inside this suit, it's nitrogen and methane. One breath without the mask, and your lungs freeze from the inside before you even feel the cold. That lake? It looks peaceful, but if you fell in, the methane is so cold that your body heat would boil the liquid around you into gas. You'd be wrapped in a vapor bubble, while freezing solid in seconds. There's no oxygen here, not in the air, not on the surface. Every breath, every spark of energy for a colony would have to be manufactured. The sunlight that reaches this place is 1% of what Earth gets. Solar panels are useless. You'd need nuclear power for everything. And the distance, 1.2 billion kilometers. A radio signal from Earth takes over an hour to arrive. If something goes wrong, you're on your own. No rescue mission, no supply run, no quick fix. A colony here isn't impossible. The thick atmosphere actually protects you from radiation, better than Mars does. The pressure is gentle enough that your habitat doesn't need to be a reinforced bunker. And there's fuel everywhere. Methane and ethane, ready to be used. The universe keeps doing this. It keeps building the same patterns, with different ingredients, over and over, everywhere we look. And I think that tells us something. Maybe life isn't an accident. Maybe it's not some cosmic lottery that Earth happened to win. Maybe life is a process, a tendency, something the universe does whenever the conditions are right.
And maybe Titan is trying to show us that Titan isn't just a strange world at the edge of our solar system. It's a question the universe is asking itself, and we might be getting close to hearing the answer.